Mastering Python Metaclasses, Deep Dive Explained. In this video, we'll uncover the secrets of Python metaclasses, empowering you to create dynamic, efficient applications with advanced customization skills. Have you ever wondered how Python can create classes on the fly, almost like magic? That's the power of metaclasses. Welcome to Mastering Python Metaclasses, Deep Dive Explained. Today, we'll explore the hidden engine behind class creation in Python. Metaclasses can seem mysterious, but they're crucial for advanced programming and building efficient, dynamic applications. By the end of this video, you'll understand how to harness their power in your projects. Let's dive in and discover how metaclasses can revolutionize your Python code. Let's start by understanding what metaclasses are. In Python, everything is an object, including classes. Metaclasses are the classes of a class, meaning they define how classes behave. Think of a metaclass as a blueprint for classes, just like a class is a blueprint for objects. While regular classes handle object creation, metaclasses handle class creation. They can customize class creation, modify class attributes, or even enforce design patterns. This makes them a powerful tool for creating frameworks and APIs. But why are they considered advanced? Because they allow you to go beyond the basic object-oriented programming principles, giving you control over class creation and behavior. As we delve deeper, you'll see how metaclasses can be a game changer in your Python journey.
It's crucial to differentiate between regular classes and metaclasses. A regular class is a blueprint for creating objects. In contrast, a metaclass itself is a class that defines how other classes behave. Imagine you're building a house. A regular class is like the blueprint for a room, while a metaclass is the blueprint for the whole house. Metaclasses allow you to control the creation, modification, and behavior of classes themselves. Here's a simple code example. When you define a class, Python uses the type metaclass by default to create it. But you can define your own metaclass to customize this process. For instance, you might want a metaclass to automatically register all classes, enforce naming conventions, or add new methods. Understanding when and how to use metaclasses will enable you to write more powerful and flexible code.
Now, let's create a simple metaclass. The process involves defining a class that inherits from type. In Python, the type class is the built-in metaclass. Let's write a metaclass step by step. First, define a class that inherits from type. Within this class, you can override the underscore new underscore and underscore init underscore methods. Underscore new underscore is responsible for creating the class, while underscore init underscore can modify its attributes. Here's a quick code example. Class myMetatype, def underscore new underscore CLS, name, bases, DCT, new underscore class equals super. Underscore new underscore CLS, name, bases, DCT, return new underscore class. This metaclass doesn't do much yet, but it's the foundation. By customizing underscore new underscore and underscore init underscore, you can alter class creation and setup. This is the starting point for building sophisticated frameworks and libraries.
Customizing object creation with metaclasses can significantly enhance your applications. But why would you want to do this? Customization allows for enforcing rules, adding functionality, or even injecting dependencies automatically. Here's how you can achieve this. By overriding underscore new underscore in your metaclass, you can intercept the class creation process. For instance, imagine you want every class to have a certain attribute or method. You can automatically add these during class creation. Consider this example: class myMetatype, def underscore new underscore CLS, name, bases, DCT new underscore method, equals lambda self, print new method added, return super. Underscore new underscore CLS, name, bases, DCT. With this metaclass, every class created will have new underscore method attached to it. This kind of customization is immensely powerful for building consistent and reliable codebases.
Metaclasses might seem abstract, but they have practical applications in the real world. One of the most common uses is in framework and library design. Metaclasses can automatically register classes, enforce coding standards, and add additional functionality, making them invaluable for large-scale applications. For example, Django, a popular web framework, uses metaclasses to register models automatically. In automated class registration, metaclasses can keep track of all subclasses, which is useful for plugins or extensions. Additionally, metaclasses can enforce coding standards by modifying class definitions or issuing warnings if certain attributes are missing. These capabilities make metaclasses a powerful tool for maintaining and scaling codebases effectively. While metaclasses offer powerful capabilities, they can also introduce pitfalls if not used wisely. One potential issue is increased complexity. Metaclasses can make code harder to read and understand, which might lead to maintenance challenges. They can also make debugging more difficult, as the source of the problem may not be immediately apparent. To avoid these issues, it's crucial to use metaclasses sparingly and only when necessary. Overuse can lead to code that's too abstract and difficult to manage. Always document your use of metaclasses clearly, and consider whether a simpler solution might suffice. Following best practices, like using metaclasses only for framework or API design, can help you harness their power without compromising code quality.
To use metaclasses effectively, it's important to follow best practices. First, decide when metaclasses are truly necessary. They are most beneficial in scenarios like framework or API design, where you need to enforce consistent behavior across classes. It's crucial to balance the power of metaclasses with the complexity they introduce. Always consider if there's a simpler solution before opting for metaclasses. Code readability and maintenance are paramount, so document your metaclasses thoroughly. This helps other developers understand the purpose and function of your code. Finally, use strategies like testing metaclass implementations separately to ensure they work as intended. By following these best practices, you can leverage metaclasses to create powerful, efficient Python applications without sacrificing clarity or maintainability. As Python evolves, so do the capabilities of metaclasses. Emerging trends indicate an increasing use of metaclasses in areas like AI and machine learning, where dynamic behavior and abstraction are crucial. With each Python update, new features and improvements can enhance how metaclasses are used. The growing complexity of applications also drives the need for more sophisticated frameworks, where metaclasses can play a pivotal role. Additionally, the Python community constantly innovates, finding new and creative ways to leverage metaclasses. As these trends continue, metaclasses will likely become even more integral to advanced Python programming, opening up exciting possibilities for developers.
Congratulations! You've unlocked the power of Python metaclasses. We've explored their role in advanced programming, how they differ from regular classes, and how to create and customize them. Remember, metaclasses are a powerful tool, especially for designing frameworks and APIs. Don't be afraid to experiment and see how they can enhance your projects. We'd love to hear how you plan to use metaclasses in your work. Drop a comment below and share your thoughts. If you enjoyed this video, don't forget to like and subscribe. Stay tuned for our next deep dive into advanced Python topics.